Have you ever wondered how your private messages stay safe while traveling across the internet? Welcome to our journey into the fascinating world of mathematics and its real-world application. Today, we explore how matrices plays a critical role in encrypting messages to secure communication. First, let's understand what matrices are. A matrix is a rectangular array of numbers arranged in rows and columns. Simple operations like addition, subtraction, and multiplication allow us to perform advanced calculations, but their true power shines in encryption. Now let us understand the basics of encryption. The purpose of encryption is to protect data by converting it into a code. Encryption transforms data into an unreadable format, protecting sensitive information in banking, internet security, and personal communication. Matrices makes this process efficient and reliable. And this is how matrices enable encryption. An encoding matrix converts a message into an encrypted form, and a decoding matrix reverses the process to retrieve the original message. This is one of the examples of use of matrix in real life, which is used in the encryption of messages. As you can see, this is a completely useless and unreadable string of words, which you would need a decoding key to understand its original and real meaning. Here is how it works in a simplified way. We first assign numbers to each letter in a message. For example, A equals to 1, B equals to 2, and so on. We can then arrange this number into a matrix, and by multiplying this message matrix by an encoding matrix, we can create an encrypted version of it. To decrypt it, the user needs to use the inverse of the encoding matrix to retrieve the original message.
Now, let us do an example of encrypting and later on decrypting a message through the usage of matrices. The message we are encrypting today is Hello WMJ, which is a sample of greeting message you send to your friends or family. To encrypt this message, we first assign all letters in the message with a number. The converted message will be a set of numbers, A equal 1, B equal 2, etc. In this case, H will be equal to 8, E equal to 5, L equal to 12, with another L equal to 12, O equal to 15, the space in between which is equal to 0, W equal to 23, M equal to 13, and J equal to 10. Combining them forms an array of 8, 5, 12, 12, 15, 0, 23, 13, and 10. Convert them into 3 3x1 matrices. We can now encrypt the message by multiplying the encrypting matrix A with the message matrices. And after undergoing multiplication of matrices, we'll get 3 message matrices in total. First of all is the 114, 109, and -3. Second matrices, which is 30, 123, and -21. And the third matrices would be 159, 154, and -89. The resulting 3 matrices is now the encrypted matrices. Stringing them together into an array will turn into 114, 109, -3, 30, 123, -21, 159, 154, and -89. The message is now encrypted and requires the inverse of the encrypting matrix to decrypt. Now, we can calculate the inverse matrix for decryption. These are the steps for calculating inverse of matrix. First of all, calculate the determinant of matrix. Secondly, find cofactor of matrix A. Third, find adjoint of matrix A by doing transpose on the cofactor of matrix A. Finally, we can calculate inverse matrix using this equation below. And matrix A is the matrix that will be used in encrypting and decrypting our message. In order to find the inverse matrix for decryption, we must first calculate the determinant by expanding the first row. The determinant can be found by using the equation below. And after expanding, we found that the determinant for matrix A is 544. Secondly, we must find the cofactor of A. Cofactor of A can be found by using the equation that was stated on the screen. And after a series of basic operations on matrices, we can find the cofactor of A is equal to -3, -45, 67, 41, 71, -9, -75, -37, and 43.
After finding out the cofactor of A, we can use the cofactor to find the adjoint of A. To determine the adjoint of A, we have to do a transpose on the cofactor since the adjoint of A is same with the transpose of cofactor. So how to do a transpose for the cofactor? To do a transpose, we have to rearrange the position of the cofactor using the format that listed in our slide. After that, we can calculate the inverse of matrix A by using the equation 1 over the determinant of A multiplied with the adjoint of A. By using the inverse of matrix A, we can finally decrypt the message that we need. We can multiply the inverse of matrix A with the message matrix to calculate the original matrices. The original matrices that we found can form the array that match the number with pattern A equal to 1, B equal to 2, etc. and voila! Hello WMJ is back again.